Hello and welcome, friends of Sudoku, to another hard Sudoku grid from sudokuexchange.com. Before I forget it, I won't be uploading a lot of New York Times hard Sudoku solves this coming week. I'm going to spend a little time working on some Sudokus that I will upload Friday, Saturday, and Sunday, and also Monday for the week following next, for the reason that I'm taking my motorcycle down to Germany for a weekend trip in 6 days. And I want you to have some videos to look at while I'm gone. And because I'm not taking my laptop with me, I will have to work ahead on those videos. And that is the reason I'm not going to upload any New York Times Sudokus for a few days. That away, let's see what we have to deal with here. A couple of 2s are blocking up, and therefore a 2 must go here. I see a 7 blocking over here and 1 blocking up, so a 7 must go here or here, and therefore at some point in time in one of these 3 squares here. 2's block over, and 1, 2 blocks down, so here's a 2. And we need a 2 for this square as well, because this 2 blocks here, this 2 blocks here, and this 2 blocks here. So a 2 must go right here. And now we have a 6 blocking down and 1 blocking up. So a 6 is forced to go in this square here. Now a 6 blocks over, 1 blocks down, so here's another 6. Let's see what else do we have. An 8 must go in one of these squares. We only need 3 more digits for column 7, and they must be an 8, 9, and a 5. Can we do anything with that? Yes, we can, because a 9 blocks here and a 9 blocks here. So this is in fact going to be a 9, which blocks over. This also blocks over, and a couple of 9s block down. So here's a 9. And it should be pretty easy to find a 9 in the top horizontal chute, because it must go here, because we have a couple of 9s blocking across. So yes, here's a 9. Five, 7, and 8 for these empty squares. Let's see. Well, this must be a 5 or a 7, and that's all we can say. An 8 here or here, yes. 4 blocks up, therefore 4 must go here or here, and therefore in one of these 2 squares. So we're looking for 4s here, here, and here. A 6 here or here. An 8, of course, it blocks over here. So an 8 must go in one of these 2 squares. And the only square that it can go is here, because we need an 8 for the column. And therefore, this must be the 5. Just 2 digits missing here, a 7, which can't go here, and a 4. So now we got a 4 and a 7 in these 2 squares. Look here, 4 and 7 block here. And we know that a 4 must go in one of these squares here, because this square is blocked. Therefore, a 4 must go in one of these 2 squares, and it cannot go here. This 7 blocks across, so the 7 goes here and the 4 here. Now we have a 7 and a 6 blocking across. We have a 7 and a 6 blocking down. So we know that one of these is 6. So now we need to figure out if a 7, well, it must go in one of these 4 squares. That's a bit much. So we'll have to let it wait for a while. We can do something with the 1s though, because the 1 blocks over. Therefore, a 1 goes here. And the last digit here should also be quite easy to figure out. It can only be a 5. And therefore, this must be a 3. Now here we are looking for a 6, a 7, and a 9. The 9 blocks here and here. Therefore, a 9 goes here. And these are in fact now 6s and 7s. Does that do anything for me? Up here we're looking for a 5, 4, and a 2. We got a 4 and a 2 here, and we got a 4 and a 2 here. So 4s and 2s must go in 2 of these 3 squares. An 8 here or here, and therefore an 8 here or here. Also not quite possible yet. But a 9 must go here, because we have a 9 blocking over, and therefore here it goes. Here we need a 7, 8, and 1. The 1 blocks up, the 1 blocks over, so here's the 1. Here now a 7 and an 8. The 7 blocks down, so the 8 must go here and the 7 here. Here now a 5 and an 8. 8 blocks here, so the 5 is forced here and the 8 is forced here. Now we have an 8 blocking across and a couple of 8s blocking up and down, so guess what? Here's an 8. 3 and 4 here, and therefore 5 and 8 here. The 8 blocks over, so here comes the 5 and the 8 here. 1 blocks down, 1 blocks over, so 1 must go here or here, and also here or here. But we did need a 2, 4, and a 5 for these squares. Now we have a 2 and a 5 in the same column, so the 4 must go here, and these now have to be a 2 and a 5. So 6 and 7 here. Therefore, these 4 squares must be a 1, 3, 4, and a 5. And that gives me absolutely nothing but a headache, because I can't place any of those. A 3, 6, and a 7 here, though. Let's see. No. I wonder if you can spot a pair, and it's in the center box. It's not always easy, but in this case, I think it is manageable. Let's look at the 2s and the 4s. We got a 2 and a 4 here, and here, and here, and here. So we know that a 2 and a 4 must go in these 3 squares. But we also have a 2 and a 4 here. So we know that these 2 squares must be a 2 and a 4. And that realization actually gives us a 3. Can you spot it? It's not obvious, but it is a logical conclusion from this 2 and a 4 pair. I'll show you. This 3 blocks down. This is a 2 or a 4, cannot be a 3. Therefore, a 3 must go in one of these 2 squares. Now look at the ramifications. And they are that this square cannot be a 3. This 3 blocks down, so these squares cannot be 3s. That means that a 3 for column 4 must go here or here. And we also have a 3 in one of these 2 squares. Now, where can we place a 3 in row 7? This 3 blocks down, so the only square where we can place a 3 is here. And that probably more or less solves the puzzle for us, because now this 3 blocks up, making this a 3. Now we have just established that one of these must be a 3, haven't we? This 3 now makes it impossible for this square to be a 3, therefore a 3 must go here. Here we are looking for a 5 and a 7, and therefore this square can only be a 4. And we had a 3 and a 4 going on over here, therefore the 3 now goes here and the 4 here. And we do remember that we have just talked about one of these being a 3. Now the 3 blocks across here, so this cannot be a 3. It must go here. This 4 blocks across, this also blocks across, and this blocks down, so here's a 4. We know that these have to be a 2 and a 4, so here's a 2 and here's a 4. The 2 blocks up, so a 5 must go here and a 2 here. 5 blocks down, 5 blocks across, so here's a 5. Blocking across, blocking down, 5 here. Here we can only place a 1. And this 1 blocks over while this blocks down, so here's a 1. We know that these have to be a 6 and a 7, so we are not concerned with them just yet. But I think we'll solve them pretty soon. Here we're looking for a 6 and a 7 as well. Let's see if we can do anything with those. 6, 7, 6, 7, 6, 7, and 6, 7. There's a 6 blocking over here, so this is a 7, and this is therefore a 6. That makes this a 6, and this a 7, and this a 7, and this a 6. One of these had to be a 7, and the other a 5. The 5 already is present in the row, so the 7 must go here and the 5 here. That was quite a neat little hard puzzle from Sudoku Exchange. I hope that you also enjoyed it and that you will come back for more soon. Bye for now.